Hello everyone and welcome back to CodeChef. In today's video, we are going to cover one of the most important and fundamental concepts in database management systems, that is, transactions and asset properties. Whenever you transfer money in a bank, place an order on any e-commerce website, or update records in a database, all of these operations rely heavily on transactions to ensure data security, consistency, and reliability. In this video, we will dive deep into what a transaction is, commit and rollback operations, asset properties, and locking mechanism, which will cover row level and table level locks. So make sure to watch till the end. What is a transaction? A transaction is a sequence of one or more SQL operations that are executed as a single logical unit of work. Either all operations succeed or none of them should take place. The transaction is basically a single logical unit of work, and whenever we are performing any transaction, there can be multiple steps involved in it. So either all those steps should be executed or none of them should take place. Let us understand this better with the help of an example. Imagine we want to transfer 5,000 rupees from account A to account B. So this operations will be performed in two steps. First, deduct 5,000 from account A, and step 2 is add rupees 5,000 to account B. So both these steps together form one transaction. If step 1 succeeds but step 2 fails, the database would become inconsistent, and that is why transactions exist. Commit. Commit permanently saves all changes made during the transaction. Once committed, changes cannot be undone. For example, begin transaction, semicolon, update accounts, set balance is equal to balance minus 5,000 where ID is equal to 1, semicolon. Then update accounts, set balance is equal to balance plus 5,000 where ID is equal to 2, semicolon. Commit, semicolon. So here we are writing a code to perform a transaction in which first we are debiting balance of rupees 5,000 from one account where the ID is 1, and we are adding that balance to another account where ID is 2. And then we are saving all this information permanently using the commit command. So if everything executes successfully, the transaction is committed. Next is rollback. Rollback undoes all changes made during the transaction. It is used when an error occurs or when the transaction cannot be completed. So we use commit to save the information when a transaction is successfully completed. But what if because of any error the transaction is not completed successfully? Then we use the rollback to undo all the changes made during that transaction. For example, begin transaction, semicolon, update accounts, set balance is equal to balance minus 5,000 where ID is equal to 1. Now let's suppose before we could add this balance to the other account, some error occurs and the transaction fails. Then we will execute the rollback command by writing rollback, semicolon. The database then returns to its previous consistent state by undoing all the changes made during this failed transaction. Asset properties. Asset properties ensure that transactions are reliable and safe, even in the presence of failures. Asset stands for A for atomicity, C for consistency, I for isolation, and D for durability. Let us understand all these terms in detail one by one. Atomicity. Atomicity means all or nothing. It means either the entire transaction executes or none of it does. And it also means that partial execution of a transaction is not allowed. If any part of the transaction fails, the entire transaction is rolled back. For example, Money is deducted from account A but not added to account B. What is it? It is an incomplete transaction. So Atomicity ensures that this never happens. Next is consistency. Consistency ensures that a transaction brings the database from one valid state to another valid state, which means all database rules, constraints, and triggers must be satisfied. Secondly, violating constraints means the transaction fails. For example, account balance cannot be negative. So it is a rule, right? It is a constraint that the balance of an account can never be a negative number. This is what consistency is all about. Secondly, primary key must be unique. So we have learned about keys in our past lessons. So primary key is something that is used to uniquely identify a record. Therefore, it has to be unique always. So if a transaction violates these rules, it is rolled back. Isolation. Isolation ensures that multiple transactions executing concurrently do not interfere with each other. Each transaction behaves as if it is running alone, and intermediate results of one transaction are not visible to others. This is what isolation is all about. It basically isolates or hides the data of one transaction from the other so that each transaction is implementing independently. Isolation is achieved using locking mechanisms and isolation levels. We will learn about these mechanisms in our future lessons. Last but not the least, durability. Durability guarantees that once a transaction is committed, its changes are permanent. Even if there is a system crash, power failure, or restart, committed data remains safe, and it is achieved using logs, backups, and disk storage. Locking mechanism. To support isolation and concurrency, databases use locks. A lock prevents multiple transactions from modifying the same data at the same time. Now, locks can be of two types. First, row level locks, and second, table level locks. Whenever more than one transactions are taking place at the same time, we use these locking mechanisms to support isolation and concurrency. Row level locks. Locks are applied to individual rows, allows high concurrency, and it is used in most modern databases. Let's see what are the advantages of row level locks. First, other transactions can access different rows. Second, better performance in large tables. This means if a particular row or set of rows is involved in a transaction, then other transactions can access different rows. It also helps in processing large tables. Its disadvantages are more overhead and complex lock mechanism. Table level locks. First, it locks the entire table, while the row level locks are applied to individual locks. Then it is simpler but more restrictive. Why is it more restrictive? Because it is locking the entire table. Its advantages are that it is easy to implement and it has less overhead. Its disadvantages are that it blocks all other operations in the table. Second, reduces concurrency. And that brings us to the end of this detailed deep dive into transactions, asset properties, and locking mechanism. This topic is extremely important for SQL interviews, backend development, system design, and real-world database applications. In the next video, we will continue exploring advanced DBMS concepts. Until then, keep practicing and keep learning.